Hi everyone, it's Sorkin. Today we have a problem when we are given an array which represents the amount of money in each house. So for example, in this case, let's say that for house 0, right, the amount of money 2, house 1 amount of money 3, and the house 2 amount of money is 2. And we have a robber who robbed each house, but the robber cannot rob two adjacent houses because of the alerting system. So in this case, and we need to get the maximum amount of money that the robber can get robbing all these houses. So how we are going to solve this problem? We are going to solve this problem using dynamic programming bottom-up approach. So in programming bottom-up approach, so what we do is we are dividing a problem into sub-problem, and we are solving a subproblem, and then we are building up to our solution. So for example, in this case, let's take the scenario that when we have, let's take the scenario when we have only one house, right? So what's the maximum amount that the robber can get if we have only one house? In that case, whatever the value is, in this case it's 2. So if we have two houses, 2 or 3, so robber cannot rob two houses, robber can rob only one house. So the maximum amount that we can get in this case is the maximum of the 2 or 3 is 3, right? How about in this case? In this case, the maximum amount that we can get, robber can get, is that the 2 to this amount, the amount that we have here, plus the so in this case, the maximum amount that we can get, either this amount and whatever the maximum we had until this point, right, until this point, or because we cannot rob the adjacent houses, or whatever the maximum amount that we got until this point, right, until 3. So what we are doing is we are taking the maximum of nums I, right, I, plus whatever the value is here, let's call it dp, right, another array, and the dp I minus 2, right, I minus 2, and or we are taking whatever the max value we have until here, right, whatever the max value we have until here, dp I, right, dp I minus 1, dp I minus 1. So we are taking the maximum value, and the maximum value in this case is equals to, so 3 and the 4. So the max value in this case is 4, and we are taking the max value is 4. But we have one more requirement here in this case, right? So the requirement is that we have also our first, and the houses are located in circular manner, and the first and last house are also connected. So these two houses are connected, right? 0 and the 2 is connected. So how, in this case, right, how we are going to solve this problem? We are going to solve exactly the same way as we are doing here. The only difference is that if we are considering the first house, which means that we cannot take the last house, right? So we cannot consider the last house. So what it means is if we are starting from the 0, then we can go to the, let's say the size of this array is n. So we can go to the, if we are starting from zeros, then we can go only to the n minus 2, right? But if we want to consider the last element, then in that case, we cannot consider the first element. So we are starting from 1, and we are going to the n minus 1, so which means that to the last element of our array. So that's exactly what we are doing in our code. So what we do is first we are checking that if our if our array is null, or the length is equals to 0, we are just returning 0. If we have one element, we are returning just that element, and if we are two elements, we are returning the maximum of the two elements. And if not, then we are starting to, so we are running our rob function twice, right? So first one is that starting from the index 0 to the n minus 2, and the another one is starting from the first index, because if we want to consider the last element, so we are starting from the first index and until the last one, right? Until the last element, and whatever is returning our as the maximum, so we are taking that as a maximum. So in this case, instead of using an array, we are just using previous one and the previous two, so we don't have to use additional array, right, in this case. So what we do is we are starting from we have our start, we have our end, and at each step we are taking temp, which is our previous one, and then we are adding that. Either we are considering the current element. If we are considering current element, then we are taking the value, the maximum value that we have until this point, right? Until I minus 2, so until previous 2, right? Until this point, plus the current element. If we are not considering the current element, then we are taking the previous one. And then we are taking the previous one, and after that we are setting to the previous two temporary, and we are going in loop until we have the maximum value for the array with the size of from 0 to n minus 2, the first run, and for the second one, array from the size of 1 to n minus 1. What's the time and space complexity of this solution? The time complexity of n, because we are going over our array only once, and the space complexity is of 1, because we don't use any extra space here. Okay, that's it for today. I also have exact solution in Python. If you like my content, please hit the like button and subscribe my channel. See you next time. Bye.